Over the past few days, we have explored the vast potential of IoT in revolutionizing the healthcare industry. Today, we are honored to have with us a distinguished academician and researcher, Professor Supriti Ma'am, who will be sharing her expertise on predictive analytics on this fascinating domain. Professor Supriti Ma'am is currently a professor in the Department of Computer Science and Engineering at JNTU, Hyderabad, where she also serves as academic coordinator and additional controller of examinations. With an impressive 24 years of teaching experience and 20 years of research experience, she has made remarkable contributions to the fields of data mining, data analytics, and medical imaging. Her research focuses on nature-inspired learning techniques and optimization of data mining algorithms, particularly in medical data analysis. She has been actively working on content-based image retrieval systems that enhance the accuracy and efficiency of medical imaging. MAM has guided 65 PG projects and 5 PhD scholars and is currently mentoring multiple research scholars. With over 60 research publications in international conferences and journals, she has presented her work on global platforms, including Kuala Lumpur, Rome, and Dubai. Additionally, she has been instrumental in academic governance, serving as a doctoral review committee member at prestigious institutions like VIT Vellore and Jain University, as well as a PhD thesis adjudicator for multiple universities. Apart from her research and academic roles, Professor Supriti Ma'am has played a key role in curriculum development, faculty training, and industrial collaborations. She has organized 8 faculty development programs and numerous workshops on emerging technologies. Furthermore, she has contributed as a resource person for refresher courses and FDPs, ensuring, ensuring the educators stay ahead in their fields. Her administrative expertise is equally commendable. She has held key positions such as coordinator of TS MSET 2018, regional coordinator for PRREDRT and TREIRBT, and has also contributed as a selection board member and subject expert for various government and private organizations. With such an illustrious career and profound knowledge in data-driven technologies, Professor Supriti Ma'am is indeed the perfect speaker to enlighten us on how IoT is transforming healthcare with intelligent data solutions. Without further ado, let us welcome Professor Supriti KP to share her insights with us. Ma'am, the stage is yours.
Yes, thank you, Vikas. So, good evening, everyone. So, I could see there are 52 participants. So, Vikas, can you just apprise me about the heterogeneity in the participants? Like, do we have faculty from different departments?
Yes, ma'am. We have
Uh,
faculty from across the departments. That includes CSC and emerging technologies as well.
So my question is like, do we have uh, only CSC allied branches?
Uh, Not exactly, ma'am. We have a few from EC as well.
Okay. Okay. Can you see the screen now? Like my PPT?
Not yet, ma'am. We can, yeah, we can see your PPT now. Yes, it is visible.
It's visible? Okay.
Yes, yes, ma'am.
Okay. So I could see few of them are in chat. Okay.
Ma'am, we have from mechanical department
Yes,
electronics.
yes. Yes,
biomedical, pharmacy.
yes.
It's a combination, ma'am.
No, that's why I asked. Like I could see here in chat, we have a biomedical engineering
Yeah,
department.
yeah. It's a combination of different departments.
Okay, okay, okay. No issue.
Okay.
So I think I'll start. So today's topic, what I have chosen is predictive analytics of IoT data for healthcare. So from past 3 days, you might have discussed about a lot of healthcare and all. So before exactly starting about predictive analytics, just I wanted to put some light on the usage of artificial intelligence in healthcare. And if you observe, AI is everywhere. Any domain nowadays, they speak about AI usage. Like you take business people, you take any domain, so they want AI. So now it has become like they're using they do data analytics, but they call it as they're using AI. As an academician, we consider it as two different streams. Like my research domain is data mining and data analytics, medical imaging, all that is mining on medical images, all that is my research domain. We never consider AI and data analytics as one stream, but industry is considering, like you do data analytics, you come up with some knowledge and use it for some profit making. They are calling it as AI. So now I want to take you through importance of AI in healthcare, and especially if you observe, so healthcare and even this insurance organizations, they are having lots of requirement in the coming days. And here if you consider, people want to automate lot of things. So in that, the why people are thinking more of AI in healthcare, so that is the first and foremost thing is they want efficiency. So they want to improve the efficiency. Like in industry, actually what is happening is, you take anything, any task, if in a day, if the task is repeated 5 times, so the industry is making them to make it as automated. That means if you are doing the same task again and again without making any change or without showing any improvement, and if the task is performed in a same way, then it should be replaced by AI. So that is the actually the need of the hour, and people are actually advocating about it. So we want to automate routine and time consuming tasks. In that, we have lots of areas in healthcare where we usually go for that. And we also have the need of personalized medicine. So this is again very important. And if you observe, usually in allopathy medicine, going for tailored treatment, it is little complex or little difficult. But when you consider the other streams of medicine, like if you consider ayurveda or homeopathy, so they treat the person, not the disease. Like we also have a lot of research happening in ayurveda, so that also coming to health, like healthcare. So here in personalized medicine, we have lots of need for AI. So here they're speaking about personalization, hyper personalization, and we also want to see how we can uh, handle a patient for a specific cause, for a specific treatment. Okay, then we also want to have like diagnosis, treatment, everything. They want to make automation. They want to minimize the human expert intervention. And as you know, so especially during COVID, all of us have observed there is a lot of requirement for doctors. So like the ratio, if you consider, it is very large in our countries, like developing countries. So when you think about the such expertise, so people want to make utility of the systems which will take up all the routine tasks, so that only expert will spend the time, or expert will look into the files only when there is a deviation. That is, only outliers or deviations should be addressed by the experts. So like this we are having. And we also have this diagnosis and treatment. If you consider 10 years back, we have not seen people who undergo regular health checkups. But now if you observe, post COVID, majority of us have become more health conscious, and many MNCs, or what I can tell, companies are insisting their employees to undergo regular health checkups, and everybody is thinking about going for insurance policies. Like when you go for your life insurance or health insurance policies, so definitely for the sake of the insurance policies we have to undergo regular health checkups. So now when these regular health checkups are going on, so this is happening massively. Like every day lots of people undergo tests. So you need not have radiologist who will like check each and everything. So people want to make again here usage of AI. Then comes data analytics, and this data analytics are done in order to make profit to the healthcare institutions such as hospitals. Along with that, it should help doctors, it should help patients. Like all the three stakeholders should get benefit out of this data analytics. So data analytics are supposed, like data analytics is providing the knowledge which will help the doctors, which will help the researchers, which will help the hospital owners, everybody. So we are, our interest is to give meaningful insights. So this particular aspect is the topic of this session. So I'll quickly go through that. We also have a lot of AI applications. So some of them might have been already discussed. Just I want to tell medical imaging. This is one of my research area, and 2-3 students have PhD scholars have worked on this, and we have worked like during COVID. Could do a lot of chest X-rays data sets. We have done deep learning techniques and different types of deep learning models we have used for diagnosis, that is for classification. And similarly, we are having different kinds like CT scans, MRIs. The image complexity increases, and classification also needs a lot of features what need to be considered. So that comes under medical imaging. So then comes electronic health records. And this is again having a lot of uses nowadays. And if you consider, normally the old doctors, the previous yesteryear doctors, they are actually giving the prescription on paper. But soon after we come out of the doctor's room, so immediately the reception will be taking the prescription and they are actually taking a scan of it. And they are actually storing all our things, like all our prescriptions and whatever the doctor is recommending, all that they're storing as a digital data. So, but what people are expecting is it is not just stored as an image, like scan when you do it becomes as an image, but they want to convert everything into electronic data, that is digital data. And this digital data again, so people are thinking about having a common pooled like a cloud service where if I'm going to different doctors, like nowadays, like if you see senior citizens, we have to visit different doctors. I have to go to ophthalmologist, I have to go to cardiologist, I may have to go to a gastroenterologist. Like when you see, so for each and every specialization, or for each and every doctor, so the health records may be shared. So that is actually need to happen, and the people are actually working a lot in India to make this EHR usage at large. And this EHR records along with regular current IoT data, so that both of these things will help us in doing predictive analytics. Okay, so I'll speak about predictive analytics. And when it comes to analytics, like data analytics, we are having different kinds of types of analytics. But among them, I am choosing predictive analytics because many people are interested in future. That is, you want to know something about future, like what happens next, what happens in 2 months, what may happen in 3 months. Like if you are able to predict based on whatever the data we have already, so that is attracting more researchers. So that is what we are doing in predictive analytics. We also have prescriptive analytics. So prescriptive analytics is you are going to prescribe how to improve a task, or in a simple way what I can tell you is, so people want to optimize a process or optimize event. So they want to optimize, that comes under prescriptive analytics. So people are also doing a lot of research in process mining. So that is again in healthcare. So they want to also deal with prescriptive analytics. Okay, so if somebody is interested to do research in it, so you can just make a note of it. Process mining or prescriptive analytics, you can explore. Then comes robot assisted surgery. This nowadays it has become a new normal, and many hospitals are having a big hoardings advertisements, robot surgery. Okay, but the decision is not made by a robo. The decision is made by surgeons. It is robo assisted surgeries. So with that, we will have more precise and minimal invasive techniques, and robo assisted surgeries are again a very successful AI applications. But when we speak about AI in healthcare, so we are having different challenges. The first one is privacy and security. And here, when you consider about privacy and security, so privacy preserving in data mining, privacy preserving in data publishing. So again, they are a very good research domain where we are having a lot of techniques, how the privacy should be provided, or how user identity should be preserved, or how user identity should not be revealed. So we are having different measures for it. And the security, when it comes to security, so we should take proper care to stop unauthorized access and breaches. And I think during COVID, all of you might have heard about, there was a security breach for AIMS server. Like AIMS Delhi server was breached by somebody. There was a security breach. So like that, we have few cases where people need to take up the privacy and security in healthcare. And then comes data quality. So here again, we are having different challenges when it comes to analytics or AI, when you think about. So we are not having data, like collecting the data from the domain or from the doctors is a little difficult, and it would be very like we'll have a lot of class imbalance problems. Like if you are having some, let us consider 10 diseases, so you may not get the data about all the diseases, that patients data. So because of that, it would be very difficult for us to handle or train or do analytics and all. Then we have this ethics and bias. So here again, AI algorithms, they usually perpetuate existing biases, and here many number of times they need to avoid like ethics, like biasing. And when it comes to AI, again, people are speaking about responsible AI. And then we also deal with regulatory compliances, that is implementation of AI. Okay, so here we have again different problems about data integration and interoperability, standardization, and as I was mentioning, health information exchange. So patient information is not being exchanged between different platforms, and people are thinking about maintaining a common EHR for all the citizens of India. So people are actually thinking about different things. Okay, so then we also have this clinical decision support, as I was mentioning, diagnosis. And if you consider, as I was mentioning, we undergo regular health checkups every 6 months. Like if you just imagine how much data we are generating with regular health checkups. And along with that, we also have some kind of government policies where we insist people to undergo checkups, the whole village, or we conduct a health camp. Like you could have seen many number of times, this vision check will happen, dental check will happen in schools, villages, everywhere. So in all such cases, they collect lot of data, but it would be difficult to have a professional intervention. So in such cases also, we need to have decision making or decision support system activities, so which will help in healthcare. Then we also have this recommendation systems. This is one more domain in computer science. So this recommendation systems, when you consider, we are having different kinds of recommendations. Like if you deal with the literature, so we actually have content-based recommendation and collaborative filtering. So content-based recommendation means based on the patient data, we give recommendation, like patient data, patient profile. So based on only the patient's need, we provide recommendation. Our collaborative filtering means, so we will find this use case based, like you're having a case of a patient, we try to find do we have a similar kind of patient earlier, maybe with the same features like age, gender, the same family history, all that. And if you have a similar thing, like whatever the previous patient has undergone, so that will be recommended. That is, we will find the similarity between the patients, and then we recommend based on the other patients' things. So that we consider it as collaborative filtering based recommendation system. Then comes patient monitoring, and especially in patient monitoring, we are using a lot of IoT devices. So here actually you are having IoT for healthcare. So patient monitoring is done by IoT, but the data, whatever we are generating, the digital data of patients, so that is used for a lot of other applications. Okay, now I'll just take up what is IoT in healthcare. So when you consider, so this is connected devices for patient monitoring. So we consider that as patient monitoring or IoT. And why we need to do predictive analytics. So whatever the IoT data we collect regularly. So that data we want to convert, or we want to look it into insights. So here in today's presentation, I will be focusing on how IoT and data analytics can improve healthcare outcomes. So I'll quickly tell what do you mean by predictive analytics, and how we can apply that to one particular diagnosis. We'll take up a case study and all. Okay, so if you have any doubt, or if you want to talk about anything or ask about anything, you are free to interrupt me. Okay, just to ensure that I have an active audience. It should not be like one-way speech. So shall I continue?
Yes, madam.
Okay, so next we will pick up. So IoT in healthcare, and if you consider, so we are having this IOMT. And if you consider nowadays, we have a very fascinating research on digital twin, especially the patients who are in ICUs or small kids who are in NICU. So once they are entering in ICU or NICU, so we may not be getting any information until and unless the doctor tells us something. But the attendants will be very interested or very much eager to know the status of the patient inside. So in order to mimic, like in order to create the exact environment virtually, so we have the concept of digital twins. So for that, actually, we need to take up lot of parameters of the patient. And for that, we are more relying on IOMTs, so Internet of Medical Things. So do you have any session on digital twins, Vikas?
No, ma'am.
No, Narendra sir is answering.
Yeah,
okay.
yeah.
Okay. So that is where actually a lot of research is happening, and you could see that usage of IOMT has become too much. And here we are having a lot of medical things like Internet of Medical Things. Even in ICUs, people are using, and they also want to have this monitoring comfortably. And we could see doctors are able to access this through their mobile. Like even though they are at home or they are at other conferences, still they can monitor the health condition of the patients who are in ICU or premier wards and all. So here, if you consider, so they are interconnected devices, and these devices will range. So as you see, many number of times we have these fitness trackers, but they are very simple. But we also have this advanced remote monitoring systems. Like we might have seen very big setups in ICUs where they are frequently monitoring the BP, SpO2, or all that. But nowadays, such big machines are not required. So they have been converted into a wearable devices or a small IoT devices, through which again the data can be kept track. And you could see nowadays, like we are having these fitness trackers, they could sense they could record and they could maintain previous 3 months data, 6 months data. So that much storage being utilized in the cloud services. So your fitness tracker or your wearable device getting connected to cloud, and the data is being stored there, and they are running few kinds of analytics on it, and then alert messages or warning messages will be sent back. Okay, so now in India we don't have yet the regular health parameter checking for insurance companies. They are asking us just to undergo at a particular time to undergo some tests, and based on that they are fixing the premium. But in advanced countries, you might have observed, so people are actually having a regular monitoring system. So that means their parameters are being tracked using this IOMT, and based on that the insurance premium will be fixed. So again, that insurance premium fixing, we again require a machine learning model which will decide about different premiums. So when you consider this, IOMT is playing a major role in healthcare as well as supporting domains of healthcare such as insurance. And when it comes to IoT, so we are having this remote patient monitoring. And not only this patient monitoring, nowadays we also have a lot of support for infant monitoring or governance, all that. And then we also have this improved patient engagement and enhanced data collection, electronic health records. All this have become very much usage now in healthcare. So what are the key components? So if you observe here, so we are having, these are the key components, and we are having a lot of sensors and devices. And when it comes to sensors and devices, like I hope some of you might have seen. So nowadays we are having a little patch, so a sticker which people are having on their shoulder or on their hand, so which monitors their BP, which monitors their glucose continuously. Like we had glucose monitoring devices, glucose machines, but that was very difficult, or it was quite pricking and all. It's quite difficult. But now if you could observe, okay, we are having this simple wearable devices or simple sticker sort of a thing, which is going to indicate the glucose levels, and it is being like they're asking us to have it for 3 days, 4 days, and based on that they are going to give us the medication. So like this, we are having new sensors and new kinds of devices are entering into the market. Then comes one more important aspect, that is IoT devices. So they use Wi-Fi, Bluetooth, cellular networks, and this is where you are having the challenge. And if you consider only in smart cities or urban areas, so we are having the continuous monitoring of the data because of the connectivity issues. So in grade B cities or in remote villages, so it is quite becoming difficult to have continuous streaming of data. Like IoT data, we consider it as stream data. We have lots of challenges in handling stream data. So data streams or stream data, so that is very difficult, and sometimes we may also get a lot of noise, lot of outliers. So that is a challenge we are having because of the connectivity issues. So then, as we have seen, it is data storage and processing. So here we are having key components, that is cloud based storage. Like just now as I was mentioning, like nowadays we could see in mobile itself, we are having like Samsung mobile I have seen, like people are using the app, so which is monitoring your footsteps, and it is going to have a record of your BP, and those are the things they are getting stored regularly, and over last week, over last month, so it is going to have the data analysis, and it may, right now it is not giving any recommendations, but maybe in the future it will also help us in making the recommendations. Okay, so then we also have the user interface. Like as I was mentioning, we have mobile apps, and patient, like doctors also having their own apps to monitoring the patients and all. And we also have this web portals, like, and as I was mentioning, EHR is again being given a lot of priority by the government, and they're again thinking about having a blockchain technology for EHR. So maybe down the line of 3 to 5 years, we will see all that in our healthcare, all government hospitals or multi-specialty hospitals. Okay, these are the key components of IoT. Okay, so then example IoT devices, I just want to give simple examples, and some of them may be being used casually when youngsters are using. Some of them are used by the very serious sufferers. Okay, so here you could see, like, we have wearable fitness trackers, that's quite common. Then we have this remote patient monitoring systems, that is again used by people who, as you could see, especially when they're in critical cases like ICUs. So then we also have the smart inhalers, and many number of times asthma patients, so they usually will have a lot of issues consuming it. So based on their situation, the inhaler should be taken, like they should inhale appropriate quantity. Similarly for glucose monitoring also, so we are having this glucose levels, and based on that the diabetes management. And we also have this contact lenses, connected contact lenses, and smart hospital beds. These are again very important. The beds are observing the movements, and then they're going to have, so that movements will be considered, or movements will be monitored based on the sensors. Like normally we have this tilt sensors, so vibration sensors and all. So based on that, we are going to use them like this. These are the few IoT devices which are already been used here in India. Okay, so that is about the IoT data, how the IoT data is being taken. So in IoT data, what I suggest you is majorly the health parameters. We may be having the user profile, we may be having the health parameters. These health parameters are dynamically captured, regularly captured through, like you can imagine it as a streaming data. And with all that data, we want to identify useful insights. And for that, we perform 4 different types of analytics. Just I'll name the 4 types of analytics. The first one is descriptive analytics. Descriptive analytics means we just understand the data and the behavior of the data by descriptive analytics. The second one is diagnostic analytics. Diagnostic analytics means some event has happened, and we analyze the data, whatever we are having, using statistical techniques, and we are going to find the cause for that particular event. So that is diagnostic analytics. Predictive analytics means you are having the data. The data will be the history data, the current data. From the history data and current data, we apply some algorithms, we apply some techniques, and we want to predict the near future. Like maybe you are having some 1 year data, you want to predict the next month data. So based on again different parameters like history data and current data, means the streaming data we will pick up. Then, as I was mentioning, prescriptive analytics. Prescriptive analytics means we will do some kind of optimization techniques, and we are going to do some kind of alert mechanisms. So that is prescriptive. But in today's session, I'll be focusing more on predictive analytics. So here, if you just observe, it's not only for healthcare, for any kind of predictive analytics project. So we actually follow these steps. So you can do predictive analytics for any domain. Any domain means you can take business data, you can take education data, you can take travel data, anything you can apply. So here what you have to do is, we want to know what is the past data you want. Okay, that is, you should identify what you want to know based on past data. So as I was mentioning, for healthcare data, we are interested in knowing the family history. So many number of times, because few diseases, whatever we have, so we always consider them as hereditary. Very few diseases will be hereditary. Few diseases come out of our lifestyle. So when you want to have such information, so definitely you require the past data. you also have some profile data. So many number of times when we visit doctor, they ask us to register, they give us an application and they collect the data. So in some hospitals, the receptionist or the nurse helps us in filling all that, or in some ways they ask us to fill all the details. So that first you should identify what data you are going to consider for your predictive analytics. The next we should consider, if you have the data to answer those questions, so then we are going to consider, we will train the system to learn about our data. So it can be like, it should be a combination, the past data and current health parameters. And then based on that, we will be scheduling our modules, and these modules will use, or these insights and predictions will help us in making the decisions. So majority number of times, these insights and predictions will help the doctors to make the decisions about the treatments. And if you observe, in healthcare, fortunately and unfortunately, so I had the opportunity, or I had the requirement to visit lot of doctors for different regions for my relatives, like senior citizens, small infants and all. So here when you consider, any doctor always goes with progressive treatment. So anybody, can you just tell me what do you mean by progressive treatment? Because we are speaking about healthcare. So these are few things one should know. So we have around 87 participants now. So not even one heard about this word. So even chat, nobody is responding. So can I just see in the chat, can people just send an hi message? Like, just I want to see how many of you are active. So somebody is telling, okay, good. Treatment for long-time care, they're mentioning. Okay. Okay, thank you. Around 10 members have given the hi message. Okay. Okay, thank you. So if you don't know the answer, I'll tell. Just I wanted to ensure it should not become one way. Okay. So progressive treatment means usually they will not start high doses treatment. So first they will have first they'll start a treatment, they do some checkups, and then they start treatment. And if people are not responding to it, then they go for next level tests, and then they'll go for next level treatment. So now let me give you a simple example. Like if we have some problem with respiratory system, first step they ask us to undergo x-ray. So they will not immediately ask us to go for MRI. It is not because of the money or the expenditure involved in it. First, they want to check whether can it be done using X-ray. If in X-ray they find something, they give the treatment maybe for 2 days. If there is no improvement, then they will ask us to undergo CT scan. From the CT scan, if they are able to find something which they could not find in X-ray, they will change the medication and they will see the improvement. If the improvement is not there, then they are suggesting us to go for MRI. So when it is happening in healthcare, they are going to do this progressively, so one above the other. Even the treatment also, they'll not immediately start high dosage antibiotics or high dosage what I can call the inhalers, what do we call, steroids. Okay, they usually push such high dosage things. So when you have like this, so the insights and predictions should help the doctor to make the decisions at the earliest. Okay, so this is one particular aspect. So we are actually focusing on predictive analytics. Like you should have your machine learning model or deep learning model, which helps us in doing this predictive analytics, and the outcome of the predictive analysis should be helpful for doctors to make the decisions. Okay, so because in healthcare we have this progressive treatment, we don't straight away go for MRI. Okay, so even when we go with some pain, so first they usually gives a little painkiller. Once the pain subsidizes, then they start giving the treatment. So this is one challenge we have in healthcare. Okay, so next, if you could observe here, so any predictive project, so we have these things. So first we will study. So we will move clockwise, like you could consider it as 12, 3, 6, 9, like this. Okay, so we will first like study how important is the problem. What is the significance of prediction here or predictive analytics here? If we consider, so this is important and predictive analytics can help us in making the decisions. So then we acquire the data. Once you acquire the data, we have to validate the data, whether the data, what you got or what you collected is right or wrong. And for this, again, we need lot of support from medical domain experts. We again go for data validation or data tagging. So this is a very challenging task now. And once you have the data ready, we prepare the models. They can be ML or DL or any kind of model we do. Simply statistical models also you can go with. And those models, after training, once you are happy with the accuracy of the model, then we will run them and we deploy on the real world. And after this, we are going to check whether they're executive backing. So whether you are reaching the targeted expectation or whether it is able to make the decisions properly. So here, these are the 5 top predictive analytics models which are being used in the computer science domain. So here, if you could observe, we are having this classification model, clustering model, forecast model, outliers model, and time series model. So these are the different models. And in healthcare, especially IoT data, what I prefer or what I suggest you is we always focus on the last two, outliers model and time series model. So outliers model means, so here you are collecting the parameters from the variable devices. So we have some values. So we should be in such a way that, so for some particular person, these are the parameters you should be knowing. So for some users, the numbers would be always high, but you need not bother about those range. But if suddenly the value is being doubled or the value is being half, so that time we should be more focused and that outlier prediction should happen. So here I'll tell, like, hope everybody has idea about the glucose parameter. What should be the glucose? What is the number which is allowed, or what is a safe value for a non-diabetic person? So you don't have anybody at home? So uh, so somebody like Shahu has given a very big answer about progressive treatment. Okay, good. So less than 90 is, somebody has given it as less than 90, non-diabetic is. So 70 to 99. Kumar Shahu, are you are you asking the chat GPT to give the answer? Are you typing it? So I could I could sense it is something you are collecting. Okay. So I appreciate the response. So if you consider here, so usually the glucose, random glucose or random blood glucose, what we consider, so it should be less than 140 mg. But I have seen people who always have more than 200, but still they're happy. So that means it is not the case that everybody should have 140 around. You may have people who always have 200. It should not go beyond 400 or it should not come below 100. So for everybody, there will be different things. Okay. So that is what actually I'm telling. It is like personalized. So personalized treatment. So you cannot have the same things. So here, if you consider outliers model is that which will help us in identifying such complexities. Then comes time series model, and time series model usually helps us or in making the different data, like stream data, we are going to observe, and we are going to have the date wise data collection. Or if you go for your BP monitoring or glucose monitoring, usually BP test, it can't be done uh, just once by the doctor. Just by checking once, a doctor cannot dictate somebody has like BP patient. So in such cases, what happens actually is we need to regularly check every 1 hour or every 2 hours. They will record the parameter. Okay, both like systolic the things, and then based on that they may have to do it. So in order to do such things, so people again want them as time series data. That is, the date, time should be captured, and the parameter should be, the two values should be captured, and all that will be given to a model, and based on that the decision will be made. And along with that, so based on other parameters, like maybe the calorie intake what you have, that is also one parameter people can monitor, the whatever we are consuming, and the number of footsteps what you are picking up, or the exercises, what kind of exercises you are doing. All the parameters will be integrated, and then the appropriate prediction, the values may be recommended. And usually it also recommends us, so for a week or for a month you can register, and we have apps which will suggest us so how many calories you should still burn to have the parameter as per the expectations. So like this, we are having lot of predictive analytics and recommendation systems, warning systems, early warning systems, all that based on IoT data. I'm speaking about only health parameter, wearable devices, data collection, streaming data, and processing. Okay. So then you could observe just this. So this is the predictive problem. So here, as I was mentioning, we have this classify, forecast, anomalies, that is outlier is also called as anomaly, and we have the cluster and we have the time series. Okay. So these are the some examples like classification. So again, here when you consider in healthcare, whether the customer or whether the patient will be with us or not. So in healthcare, we are majorly focusing on anomaly, like whether the values are fraudulent or something. This is in general a case study. I have just kept it, and people are also going for clustering. The patients can be grouped, and the treatment will be given it in that way. And we also have this forecasting, as I was mentioning, the BP or the sugar that can be forecasted. So these are the common, widely being used predictive algorithms. So it's a random forest, and we also have this generalized linear model for two values, and we also have this gradient boosted model, k-means, ARIMA. So k-means is data mining technique, and ARIMA is a pure statistical technique for time series data. So these are all few algorithms which are being widely used for healthcare IoT data. Okay, so I'm not going into deep into that. I'm just going to discuss about one case study. Okay, so here if you consider predictive analytics in healthcare, so it usually leverages advanced statistical methods, machine learning algorithms, and big data analytics. So to forecast future health outcomes based on historical and real-time data. And for this real-time data, we actually have to consider uh, the wearable devices, that is IoMT. It can be Internet of Medical Things. So these are the wearable devices. And here key benefits of predictive analytics, if you just see, so we are always interested in early disease detection. And this is what you could see, like one of you have mentioned in the chat about the cancer treatment, like radiotherapy, chemotherapy, all that you have mentioned. So when you go with cancer, lots of people cancer for different organs. It's a quite a dangerous disease, and if the cancer is detected in stage 1, you can easily get addressed, or you easily get treated, and you could be safe. Okay, so if the cancer is being detected at a later stage for a patient, it would be very heartening and it will be very difficult for the doctors also to treat. So because of that, people are very much interested in early disease detection. And one more aspect, what people are expecting the AI or expecting the healthcare solutions is they want to give warnings, or they want to give some hints what may happen in coming 2 years or what may happen in coming 3 years. And you could see, especially these years, like from past 1 decade, you could see lots of elderly people suffering with Parkinson's, Alzheimer's. These are the things. If you could find that somebody is prone to such disease, so we may take some measures to avoid that particular disease. It is not disease detection, it is disease, what I can tell, prevention. Like you, if you have little probability of getting some disease, and if you take proper care, you may prevent it. It is not coming to us at all. So these are few things, like people actually give different regions and different data is required to think about the early warning systems. So this is early disease detection, but people also want preventions. And then we also have this personalized treatment plans. And this is again very important. Senior most people will usually do this personalized treatment plans. And many number of times we have seen experienced people or the doctors who are able to address the problem. So many number of times the problem will not be identified by doctors even after we undergo lots of tests, but the region would be something else. Like I have come across a case of one of my colleagues. So I was shocked to know, so a small tumor in brain is causing a problem which nobody can identify. uh, so when you have like that, so regular treatment will not work. So you need to study a person and you should give a personalized treatment plan. So we have like this, the personalized treatment plans. Then we have operational efficiency, and as I was mentioning, preventive care and enhanced decision making. These are the key benefits of predictive analytics in healthcare. Okay, so then we'll see how to integrate IoT and predictive analytics, how IoT data is collected and analyzed. So as just now we have seen, we have wearable devices and implants which track vital health metrics. So if you could see even the heart data that we normally call it as ECG. So even that, or the brain signals, or even the EGG, the egg, the thing pertaining to our vocal cords. So all these things, people are having the devices which can be implanted and which can keep on giving the data. So that is to track vital health metrics. We are having a lot of implants, and we also have simple wearable devices such as your bands or your fitness trackers, like that. And then, as I was mentioning, using Wi-Fi, Bluetooth, we are going to sync all the data to a cloud-based storage. And from there, we run the analytics. So how do we run the analysis or analytics? So here, these are the different steps we have. First one is pre-processing. So this is very important in any analytics. First, we should validate the data, and we should see that the quality of the data is utmost important for us. And when do we tell the quality is good? So that is, again, we are having different parameters to check, and we should see that we should not have more missing values, or we should not have noise, and we want to see that the parameters, whatever we are capturing, is all features important for us. And we want to see that you normalize the data. And sometimes we are collecting data from multiple sources. When we are collecting data from multiple sources, we should see that in the integration part, you should not leave any kind of error. So you should integrate, or the data should be merged in a smoother way. All that we are going to handle in data pre-processing. And we have different techniques, like we have a statistical techniques and mathematical models, which will help us in doing the pre-processing. Okay. So then comes the machine learning, or I can tell nowadays we have lot of deep learning for images, and especially for MRIs and all. We are using pre-trained models such as AlexNet. So long back during COVID, we have got a very good publication. So where a scholar has worked on AlexNet. So pre-trained AlexNet was trained on chest X-rays, and then it has been used. Similarly, for brain tumor detection, we have seen a lot of scholars who were applying the deep learning techniques. Okay, like this, we are having a lot of medical imaging, the usage of ML as well as the deep learning models. And then comes predictive modeling. So we train the model usually for classifications, and predictive models we always use for forecasting the health risks. So these predictive models will definitely forecast or may help us in predicting the future, which helps us in doing early detections. Okay. And another thing what we do is real-time monitoring. That is, the data what we are doing for predictive modeling should come as real-time data from the wearable devices. Okay, so this is one case study. Just I wanted to have it as a roadmap of implementation. So here we could see predictive analytics for early detection of heart disease. And very sorry to tell, especially from past 10 years, we could see, so irrespective of the age, earlier, like when we were in 20s or 30s, so we used to hear the heart attacks used to come only for elderly people. But now it is very sad to know the heart diseases or heart attacks are being occurred in very young age. Lots of students or lots of young software engineers. The region may be anything, but we are having lots of chances of getting heart disease at a very young age. So in 20s, 30s, people are having lots of problems. So how to avoid that? How to preserve? And as you know, now we have Amritkal, and India, we are thinking about becoming Vishwaguru, and the much strength about our nation is our young people. And in many platforms, we always tell, we are very happy to tell, like we are having a very good demography. And with this, when we consider about our health care, if we take proper care about health of our citizens, only then it would be easy for us to master. Like I don't know how many of you have observed, so we could see lots of health issues in young students. Like when we were students, so it was very rare to have a people problem health issues. But now you see lots of people, like in every class we are having definitely 3 or 4 people who suffer with health. And at a very young age they are having lots of issues, like it can be either heart issue or spinal cord issue, like different problems. So now here even the government is making or taking proper care to protect the health of youngsters. And because all of us are in teaching and we are all addressing the engineering students, so I appeal to you as a senior or as a academician. So we should also warn students about their health. So we are not just telling about the subject, we have to warn them that health is first, and we should try to inculcate good habits, and we have to take it as our responsibility as teachers. Okay, so here when it comes heart disease, we have seen lots of ages. So earlier age, and again people were having a bent of mind long back, like 2 3 decades back. So male used to get more heart diseases, but now there's no gender bias, there is no age difference. We are having lots of cases. So here what people want is, hospitals already being practicing this, they have successfully implemented predictive models. They are able to identify high risk individuals for heart disease. And here again, if you could observe, so many people blindly they tell, like whoever doctor you visit, the first thing what they tell is like reduce your weight. So that is one common thing almost all doctors are telling. And there is a notion, or there is a hint from the doctors is obesity causes heart diseases, like obesity causes respiratory problems, like they're having it. So like this, based on some parameters, they will be able to identify high risk individuals. And here when you consider, so we are can do advanced data analysis and using machine learning, and we can assess patient health data. And here in leveraging data-driven insights, so as I was mentioning, data collection and pre-processing, so we gather patient data from electronic health records. This is again important. So you may have to handle a lot of health records. Okay. So I just tell my example. Like when I was doing my research rigorously for submission of my thesis, I actually had, like I was carrying the laptop more, and because of that, usage of laptop was more, many hours per day. Like I got some issue in cervical spondylitis. It was way back in 2006, something like that. But now I had some other issue with my headache and all when I visited. So I have to tell about what kind of problem I had that time. 2007 means it's almost 17 years back or 18 years back. But when they started asking, so it was, I don't have the type of medicine what I have taken that time, or I don't have. But here what is happening is, so if you have this EHR, so the electronic health record, so definitely it makes sense, or it helps us in keeping track all our data. And many number of times when we have, so sometimes we have different issues, like for kids or for elderly people, the senior citizens at home, so they'll have different issues. Sometimes we visit ENT, sometimes we visit dermatologist, sometimes we visit ophthalmologist. Like different people, we have different kinds of medication. And when you go for a new doctor for a new problem, it is our responsibility to indicate about all other medications. Okay. So now the EHR is one particular aspect which helps us in maintaining all that records. Okay. That is the significance of EHR. But it takes time. Right now it is not up to the mark. So still many things have to be taken up, and many frameworks have to be built up, and we should insist every doctor and every patient to move towards EHR. Then these wearables and IoT devices, the cost of these devices should also come down, so that even normal people can afford for it, or government should be able to provide them for a subsidized rates, all that. So all these are required. And once you collect the data, like as you could see IoT devices, as you have the ECG, BP, cholesterol, all that. So it is very important how we are collecting the data, then we normalize the data. So normalize is nothing but we want to bring it into a small range. The values what you have, you want to bring it to a small range so that I can apply a very comfortably statistical modeling techniques on it. So cleaning is avoid noise, or usually we replace noise with the more relevant value. Then handling missing data. So missing values are also can't be ignored. So you may have to make an attempt, give an alert message to alter the wearable device or charge it, or keep track of that wearable device properly so that you get the streaming data. Then comes feature selection and engineering. So that is, we need to identify the key predictors. That is, which are the parameters which are very essential for identifying the heart disease. So here we need to prioritize the features which will have a highest impact. So here we are using some dimensionality reduction techniques. Okay, so such as principal component analysis, and we also have feature extraction techniques. Okay, so like this, we are having feature engineering. And after that, we go for training the predictive models. When you go for so logistic regression, So that is here we want to check whether the heart disease will occur or not occur. So here we are having this binary classification, and that also we are doing, like we are extrapolating. So with this current data, maybe from next 2 months, next 3 months, what may happen. So here we use that, and people have also proved that random forest has achieved more accuracy because it is using more decision trees, and it is making it most reliable. This is one paper we have referred for heart disease detection. So then we also go for evaluation and optimization. That is, once you have the model, whether it is ML model or DL model, so you want to improve its accuracy by using different boosting techniques. We usually do parameter tuning. And then we also deploy this model on cloud-based systems, which will be integrating with IoT devices. And we also want alert messages, that is real-time alerts for high-risk patients, and which will help us in early interventions. And along with that, we also need to validate real-world clinical settings, and that should be integrated with hospital management systems, which helps the doctors to make the seamless decisions. Okay, so with this particular thing, so it has been observed that, so we are having timely diagnosis, cost saving, and we can provide improved patient care. So for this, we require the past data and we require real-time data. Real-time data has to be captured by IoT wearable devices or IoMT devices. Okay, so this is about the case study. We can have different kinds of models. As I was mentioning, for diagnosis and all, we can use deep learning models as well for images. So, but for heart, we have actually, we undergo this treadmill test, we undergo this ECG, all that. Okay, 2D echo. So these data is again have to be considered as signals processing, and from that we pick up some patterns, and then based on the regular heartbeat parameters. So time also is very important. So many number of times, different time periods, you will have different heart rates. So all such things, time series analysis is also done, and based on that, the risk will be, or alert messaging will be done. So then we go with this challenges and solutions. As I already told, data breaches, it's a very thing, and sensitive health data is a prime target, and we need to take care, a very good care about it. And as just now I was mentioning, so AIMS Delhi server was actually hacked for some hours, it was down. So we had such issues. Okay, then we also have this disrupt operations and delay in patient care, and we have some regulatory compliances. And actually in our country still we need some government policies to come, and enforcement of that should be handled properly, and people are working on it. The higher academicians and researchers are working on it. So then we have different challenges, like data silos, that is fragmented patient information. It is available in different doctors, different partitions, we call it as data silos. Integrating all that is definitely a challenge for us, and we don't have a common data format, as a lack of a common data format. So for that we need to have some standardizations. And as I was mentioning, you cannot mitigate, so you need to have maintain privacy. Again here, privacy preserving in data mining or privacy preserving in predictive analytics is a major concern for us. So then we go with the future trends. Okay, so give me one. So here let us have some light on future trends. So as I was mentioning, EHR is about to come, and electronic health records is becoming a mandatory for us, because we need to have a lot of technology intervention in healthcare. Along with that, we also have this telehealth and remote monitoring. Like we have this kind of medical transcription from long back. So, and thanks to COVID, which has actually promoted lot of medical assistance or doctor assistance over WhatsApp. So WhatsApp video calls, people are using a lot instead of go traveling long distances and interacting with the doctor. So for many times, many people are actually, when I could see, when like a few advertisements have also come up with respect to dermatologist. So video call, they could observe and they will suggest us the medication, or diagnosis can be done and the prescription can be done. Okay, so that is telehealth and remote monitoring is having. And this particular feature is very much useful to the village or remote places, especially if you observe we are having these hilly regions, or we are having very remote areas where we are not having lot of comforts, and it is very difficult to have doctors in those places. So in such cases, so the government is taking lot of care, or lot of policies are coming up to promote this telehealth and remote monitoring. Okay, so that is, we need to go for virtual consultations, real time patient monitoring. And in that again, we may be having, so here IoT may not come into picture, but as you see, we may be having a sort of video conferencing mechanism or a video capturing mechanisms, so which will help the doctors in keeping track of the patient data. Okay, so then we have this blockchain in healthcare. And here, if you observe, blockchain technologies, people are using a lot. And nowadays, actually, people are thinking blockchain means cryptocurrency. Like people are just using blockchains for cryptocurrency, or it's something relevant to banking. But the blockchain technologies are very much appreciated even in pharmaceutical industry. Blockchain technology is appreciated even in revenue department. So here, blockchain technology can also be used in healthcare. So that is, we want to have a secure, decentralized medical data management. And with this blockchain technology, so you could see a lot of strength and data privacy. Okay, yes, somebody was mentioning agency areas. Okay, that's also correct. Hilly areas and agency areas, they're very remote. So that is one particular aspect. The telehealth and remote monitoring is very much required. And blockchain, as you are mentioning, this technology is definitely taking over. And coming 5 years, you could see blockchain also gets embedded with healthcare. That is, you will have IoT, you will have deep learning technologies, blockchain is coming into picture, and EHR, a very a centralized cloud will come, where total citizens' data will be available for the sake of government. All these things have to be planned. So then comes this 3D printing. And 3D printing, if you consider, lot of already been used for prosthetics. Like people usually go for artificial limbs, artificial things. So for that, actually 3D printing is being used. So there they have here bioprinting tissues and surgical models, everything. So medical devices will definitely have a lot of revolutionary with the help of this 3D printing. And then we have robotics. And we also, you might have some of you might have also studied about robotic process automation. And we are actually having this lot of procedures where the process need to be uh, assisted. And as I was mentioning in the starting of the class, so people also bother about process mining, or they want to see optimize the process. So just I'll share one experience of mine. Like one of my relatives were undergoing colonoscopy in a very big hospital, and I have to accompany. So when I was accompanying that lady, so I could see they are scheduling this endoscopies, colonoscopies, a big group, like they're scheduling for lots of people same time. And all these tests, they'll take morning time. And a doctor don't want to waste time. and they will be preparing. It is almost like you could observe it as a supply chain management sort of a thing. Like they are in a pipeline, like somebody is getting dressed, somebody is undergoing some kind of treatment, then they are being transferred to some room, and from there they are going back. So all these things, they're having around 5-6 different steps for different types of tests, and they want to optimize. And the doctor was very much angry because he was made wait 10 minutes idle there. So he don't want to waste even that 10 minutes. That means that process, what is happening there, the process, they want to make it in so efficient or optimize in such a way that doctor time or the nurse time should not be idle. Okay, so when you think about this, so we require, so that healthcare, so people definitely need this prescriptive analytics or more of AI assisted procedures. Okay, so here again we are having rehabilitation robotics, and nowadays, especially during COVID, we have seen lots of people who are actually suffering with psychological challenges or psychological disorders. So for all that, so people are actually looking for more and more analytics also. Okay, so the impact would be we have higher precision, reduced recovery time, and we definitely have more satisfying patients or happy patients. Okay, so then we have this future outcomes, an interconnected healthcare ecosystem where IoT devices, predictive analytics collaborate to deliver faster diagnosis, optimized treatments, enhanced patient outcomes. So here, this ecosystem, it transforms healthcare into a proactive data-driven model. So as I was mentioning, the doctors and patients, they will collaborate more effectively. Okay, so this is about my class. Like these are the references what we have referred, different research articles from conferences and journals for preparing these slides. Okay, so thank you. I'm happy to see that majority of you were responding over chat. I appreciate that. And I appreciate Kumar Shahu, who could give a very lengthy chats and a lot of information. Okay, so that's all from my side. I think we have last uh, 8 minutes or so, 5 minutes or so. If you want to interact, so I can interact with you. So you want me to share the references? Okay, I'll share. I'll share PPT with the organizers. Maybe they may share it with you. It's not an issue. So Kushi was asking for it. I'll share with Narendra sir. Yes, the question is how accurate will be the prediction based on data collection, which might be incomplete. This is the reason we have to pay more focus on pre-processing, because this is healthcare. And as you see, it is like let us consider you are diagnosing something. If actually the patient is not having the disease, but if you diagnose, so that creates lot of agony to the user or the patient. Okay, that's why it is very important to increase the accuracy. We are not supposed to have true negatives or false positives. We should not have them in healthcare. Both are dangerous. Okay, and where can we get the data sets for IOMT? So data sets, it is still a challenge for us. Maybe I don't know about the data sets of IOMT, but what we have seen is you have to collaborate with any MNC, like multi-speciality hospitals. So from there you may collect the data. So again, there the privacy preserving, they usually clip the patient name, address, everything, and they will share with you this particular IOMT data. So how can we integrate data from wearable devices and sensors to understand patient behavior? What do you mean by patient behavior, Kushi? Normally, what we do is only the lifestyle may be monitored. We may not be able to understand the behavior. And again, here you may have uh, health behavior. So this is again the values what you are having, ups and downs, you may have it. But we also have one more challenging apps, or the requirement is, so especially these young people, if you observe, so it is always better we integrate even the data what you are collecting from your social media. Like in social media mining also we tell that. So now let us consider, especially with respect to this psychological assistance and all, if you want to provide, so it is always needed for us to know their mental status. And there, it is not just BP parameter, glucose parameter. We should also observe their facial expressions. We should also observe what kind of posts they are making, what kind of interactions they are having on social media. Like that, we may be getting the data from multiple things. Like you could see Google, if you observe, so you are using Google. So the Google Maps, whether you book a cab or not, so your previous navigation patterns are being handled or being tracked by Google Maps. So like that, so you are supposed to have this type of integration from different things, and then based on that the behavior may be predicted. And here, when it comes to sensors or wearable devices, so as I was mentioning, so if you are monitoring glucose, for some persons, glucose level is always 200. For that person, you cannot apply the common model and you can't tell always it is danger. Okay. For some persons, it is always 90, 90, 90. Like this, personalized predictions or personalized diagnosis should be done. Okay. Hope I could answer you, Kushi. Like integrating the data is very important. Are there any available resources that can help us to research in these areas? Yes, you have a lot of research. As I was mentioning about digital twin, you just search about digital twin, you will get to know a lot of research scope, research gaps have been discussed. Okay. Is it possible to predict the diabetic spike by this method? That's what I'm telling you. So here we may need to have something like a Google Glasses. Like what you're consuming should also be monitored. Like what you eat should be monitored, and how much, what I can tell, the insulin is being generated in your body can also be predicted. Okay, that is what is actually coming. That's what is actually required. So right now, what you are eating, normally the apps what you are having is they are asking us to enter the calories how much you are consuming, but many number of times we may not be measuring all. Like you could have seen, we have some apps, if you just roll over your phone over the plate, it gives you how many calories it is having, but it may not be accurate. But the app will process the image, it identifies what kind of food it is, and based on the quantity it will tell how many calories it is having. Like this, we are having lot of inputs. From that, the diabetic spike should be identified. And one more important thing is, whatever the data we are having, so it can't be done complete 100% accuracy, because many number of times you might have observed, health majorly depends on your state of mind. That we have to believe. Like a happy person may not never have any kind of a issue, whatever may be the parameters. The positive mindset, or looking into positive aspects, and keeping yourself satisfied, like you might have heard about all that. So in such cases, somebody is under stress, somebody is having some work pressure, so definitely you may have these diabetic spikes. So we have lots of parameters we require, but how do one check the stress in your body? So that again depends. Okay. So like this, we are having several parameters. Right now, we are just speaking about the IoT wearable devices data only. But internally, we are having lot of other parameters which influence these parameters. Okay. So still research need to happen, and we need to promote all our citizens to utilize this and to stay healthy. Can IoT-based smart prosthetics improve patient mobility through real-time neural signal processing? And what are the limitations? Actually, the research is going on, and I could see few videos where this smart prosthetics are helping the people in mobilizing, and they're also actually just by observing the eye movement, they are able to respond. Like if a person is having a prosthetic hand, so if he wants to move it, the brain fingerprinting we call it as. So people are actually even doing research. It has not come into a product still, but uh, we are having those things. Like right now, it's only based on the vision or the eye movement, the signals, oral instructions. They can become smart, but if it could understand the brain technology, if it gets embedded, so you will have wonders. Okay, so thank you.
Yeah. Yes,
Okay.
sir. Thank you, ma'am, for such an enlightening session. Your insights into IoT applications in healthcare, particularly in data analytics, have given us much to reflect upon. Thank you so much, and we would look forward learning from you in the future.
Okay, thank you, Vikas. Thank you everyone for your attention. Okay, the chat was also good. Like many people have responded over chat. Okay, thank you very much.
So, as we continue with our faculty development program, we are privileged to have yet another esteemed expert with us for the next session. It is my pleasure to introduce Mr. Jayasimha Aditya. Mr. Aditya is a seasoned professional with expertise in data analytics, leveraging insights to drive business decisions. He has delivered impactful IoT sessions across multiple colleges, equipping students with real world applications of emerging technologies. With over a decade of corporate experience, he bridges the gap between academia and industry through hands on learning. As the founder of as the founder and CEO of Mediocity, he is committed to transforming education with a balance of theory and practice. His passion lies in mentoring, skill development, and empowering professionals for future ready careers. With that, let us extend a warm welcome to Mr. Aditya, and I now invite sir to take over the session.
Hello, everyone, and thank you so much for warm welcome, Mr. Vikas.
Thank you, sir.
So, good evening, everyone, and it's a pleasure meeting you all. So, I would just give you a quick background about myself so that you guys will be aware about what exactly is my background. So, like Sir said, I have a decade years of experience into. So I started my career as a business development, and after that, I slowly moved towards the data analytics part. And after that, I started working with multiple companies in terms of building edtech platform, and also I did give a lot of speech to multiple colleges. So I might be not the best expert as compared to you guys, but at least I can give you a guarantee that I will try to answer as many questions as possible. So yeah, so today we are talking about the evolution of healthcare in in the analytics part, and how healthcare is moving into the IIoT part. So my company, so we started a company named Mediosity, and we are in the verge of evolving the medical science into more enhanced way. So that's where we are evolving the medical, technologies in the current market. So taking that into account, so I will be talking, I'll be talking a bit of that and bit of this. So that way it becomes very easy for us to for us to take things more better way. And first thing, I have to be like very thankful to the ma'am who actually just took the session. So a lot of questions you guys were asking, and I really enjoyed that. Okay, so let's not waste enough time. And when we are talking about healthcare, okay, everyone sees that there is a lot of there is a lot of evolution happening on a everyday basis, and we are trying to move from traditional methodology to AI driven methodology. The reason why these shifts are happening in a more drastic way and in a more dynamic way is because AI has proven a lot of times that it gives a lot of precision engineering, like it gives a lot of precise information. And how are you trying to do that? Of course, you are playing data analytics and your data analytics, data science, and big data is something which is which is the core information on artificial intelligence. By taking that into consideration, we even have a lot of technological shifts, and we even have a lot of reactive shifts happening to in the current era. What we can see, or what are we trying to do over here as a technology is, we see that all the manual are moving towards technology, and from technology it is becoming more on early stages diagnosis, or people who are sitting from multiple areas, so they are trying to solve the problem at another area for giving a more faster and more quicker shifts. So when we are talking about technology, AI is one which has data science and big data, as well as, sorry, data science, data analytics, business analytics. So all those areas falling under AI is the main core areas. The next one is the IoT and IIoT. In IoT, there is one transition which is happening. IIoT is becoming more like an industrial Internet of Things. So these two are more in line with what is happening on the real time. The third one is the robotics, where we recently have seen a lot of information saying that, okay, so there is a patient sitting in one particular area, and there has to be there has to be a operation happening in another area. So people are working remotely and trying to do the operation, maybe in a different time zone, but that kind of evolution is also happening. Robotics is also playing a very important role to take care of the patients and to make sure that they are being monitored 24/7. So I don't know if you guys are aware about this. In UAE, there is a hospital where they have nurses which are robots. So what they do is they actually take care of the patients 24/7. They are monitored every time. If they see that the robot is, I mean, if the robot is detecting that the patient is having some sort of difficulty, it is immediately sending a message to to the doctor. Again, this is all interconnected technologically. So let's dig in more in detail about how and what kind of shifts are happening in the real world. Okay. Now, why is this important, or why exactly is this changes happening over the period of time? It is said that every healthcare expert has to have multidisciplinary knowledge, which means it has become mandate that a doctor or a health practitioner has to know the technical side of it, as well as the patient side of it, because nowadays the healthcare experts, their knowledge expansion has widened more, and they have to be very well aware, because there is a lot of research which is happening, and that's where healthcare people are facing healthcare people are having a lot of intense knowledge on that. Now, again, when we are talking about the opportunities, the research and innovation opportunities over here, engineers, how important engineers are playing their vital role. It is the same thing even with med people, like anyone who is into medicine or anyone who is into the health tech. So these people also play a very important role, because I can give you an example. This is where I am doing my research right now. So there is there is something called as medical writings, or there is something called as data writing, okay, where what happens over here is when there is when there is a biomedicine engineer, there is a med engineer who is doing a lot of research. This majorly happens in multiple labs. So everything has to be written down by the doctors, and after that, it is being pushed to make sure that this is moving on an AI channel, so that when there is a prediction happening or when there is a diagnosis happening at particular hospitals, so doctors are asked to have that search page into, have that search page so that they are going and reading in detail about that particular research. This is something where I'm doing a little more research, so maybe I might not explain you so better. Apologize for that. But this research which I'm trying to do is I am talking to a couple of doctors and I'm talking to a couple of engineers, so which is tech engineers. So where they are working at multiple labs, and these people, what they are doing is, if there is a drug which is coming out, let's say if there is, we call that drug development, right? So if there is any sort of drug which is playing an important role, they are pushing this drug into artificial intelligence, and all the diagnosis and everything is completely mapped under a certain area where there is a lot of image stitching and there is a data stitching happening. So whatever they got the previous information about it, they have to try to map with the current, with the current result. So with this, what is happening is the research and the innovation behind a single drug has become more important. So over here, engineer plays an important role in stitching the data so that he is correctly mapping, saying that, yes, this is the sort of information and this is the sort of predictions that can be happening to facilitate the entire operation. So that way, the innovation is also playing a very important role from the engineer side. The research side, the doctors and the medical people. So this is something where the bridge between engineers and doctors are actually being made. Um, so the next one is empowering students. So where exactly the graduates can look into. So people who are into engineering side, so they can look at areas of data analytics, or they can look at areas of gathering enough amount of data. So not into business analytics, because business analytics becomes more like a managemental functional role. So people who are very, who like machine learning and who like, of course, data analytics or data science. So people who really enjoy working on deep learning or NLP or those kind of people, they will be the next future who would be working on healthcare innovations. And in the medical side, someone who is into pharma, someone who is into doctors. So we have, PhD and research analyst people out there. So people who are into such kind of areas, even they are being chosen to work under a lot of innovative, under a lot of innovative environment. So we call them as incubators. So that is something which, is happening in empowering the students. So if in your college, if anyone is asking what is going to be the future into healthcare, this is the future. Again, more in detail about that, there is a lot of IoT changes, and there is a lot of, there is a lot of technology changes and everything. In the previous discussion, someone was asking about wearable, about wearable bands, right? So, Mr. Mustafa, can you hear my voice, or is there a challenge?
Yes, sir, you are audible. No issues with your side.
Perfect. So yes, so when we are talking about key differentiators in artificial intelligence, the first thing first is we see that there is a lot of AI driven changes. Now, how we are trying to work out on the AI driven changes is we have a lot of diagnosis which is happening, and there is a lot of personalized medicines which is provided. So I'll give you a quick background on how this is working. Okay. So let's say that there is a cancer patient. Okay. And this cancer patient is having stage 2 or stage 3 cancer. Okay. Now, when we are talking about stage 2, that means he is in, he's still in an intermediate position. Uh, Sandeep, I cannot share this. Yep. So yeah, so when we are talking about how AI and ML is working together, so one thing, when a patient is coming with a certain disease or with a certain problem, so it becomes very important, or it becomes very personalized kind of treatment which should be provided to the patient. Now, that is something for a cancer. So we have a lot of diseases which are very much neuroconnected, and which are very much, which are very much connected to the entire body. So we call that as neuro problems, or we call that as brain issues. So such kind of issues are there, and there are a lot of certain diseases which do not be diagnosed just immediately, but they will take a lot of time. They will do a lot of research, taking that patient and doing a lot of work. So such kind of diseases are a lot in this world. Now there is a lot of diagnosis also happening. When this kind of things are happening, we have to provide personalized medicine. And for that thing to happen, every diagnosis undergoes a certain set of stages. So certain people, they ask to do physiotherapy, certain people, they ask to follow home remedies. So certain diagnosis works on diet, certain diagnosis works on your fitness, like health fitness. So these kind of diagnoses have to be properly jotted down. Now, how these kind of predictions can happen from engineers is, engineers actually make a list of all these things, having tied up with multiple doctors, or multiple health experts. So in India, we have Pfizer, and we have Narayan Hrudayalaya, which is in Bangalore. So these two are the major diagnosis, centers where they work on understanding the diseases happening on a day-to-day basis. So over here, how they are trying to do is, so let's say that there is a prediction, and nowadays we see that a lot of people have ADHD. ADHD is a very old problem. So nowadays, why we are finding a lot of people, we see even students having that. Even to be very honest, in a very younger age, even I had ADHD. So why this ADHD has become a very important problem in the current generation? So, and how this is being solved? So these kind of personalized medicines or personalized information, AI is building right now. Why is it important? Because there can be a lot of other diseases which we will be coming in the future. But to keep it more simplistic, these kind of analysis and these kind of predictions have to happen parallelly and in a more equivalent way. Now, the second thing is Internet of Medicine, medical things, or IoT. So that means when we go to hospitals, we see that the patient monitoring has changed a lot of things. So nowadays, what they are doing is, if you have any kind of problems, they send a pill inside our body, and they will be attaching a camera to it. We might have heard this kind of news, right? So I'll tell you what is the future of this. Currently, they are just sending a pill. And in the future, what is happening is, they are going to have a light attached with that single pill, and there will be a rope which they will be asking the patient to drink some water and then have that medicine inside. So once the medicine is going inside, this entire they are attaching that with an edge device, which is which is again sent out to the which is again sent out. That edge device will collect all the data and information, and based on that, the AI is going to give a predictive analysis on what kind of problem that person has. Now, when that problem is being detected, what happens is it becomes easy for the doctor to cure the problem. If I have to give you an example, so there is a hospital in Brazil where it is called a smart hospital, where they use all the latest technologies, like be it with artificial intelligence, be it with IOMT, or be it with IoT. So they are using all the latest technologies. So by the end of the session, I'll give you the hospital's name. So why they are using these kind of, why they are using these kind of devices is, first thing is first, the diagnosis becomes very easy. And if there is any serious issues, they can try to track down. And of course, that is going to make their life more easier. The third one is big data and cloud computing. Over here, big data is going to help to fasten the entire process, fasten the entire diagnosis process, so that the healthcare person is able to make a decision more faster. He's not taking days along. So if I have to talk about traditional methods, like in the past, what they used to do is the doctors used to be skeptical on what kind of problem it was. And the decision used to take a lot of time. For few hospitals, it used to be days. For few hospitals, it used to be months. We never imagined that, okay, a cancer treatment can be cured in a short span. So this kind of evolution became more often when we started having a lot of big data and cloud computing, which came into place. Honestly, in India, back in 2010, after 2010s, we saw that there was a drastic change in the diagnosis methodology, where the doctors started making more faster decisions and more effective decisions. Actually, they saved a lot of cancer patients. So the data is available in the the data is available in the internet. So you guys can have a look at that. So imagine such kind of large data sets or large data, which is again looped into LLMs and data centers. So these things are making the diagnosis more faster. So this is how the differentiator for the for the technology side is happening. Now, when we are talking about so this is the hardware side, the robotics and automation. So every one of us know that Yashoda has started something into robotic surgeries and robotic operations, right? But how this entire thing came into existence, where engineers came into existence, was uh, we saw that robotics plays a very important role because they are being commanded, or I can rather say that they were being designed in such a way that their coding is very precise. So if they are being said to cut at a particular centimeter, the robots are actually doing that that deception, so which is cutting, so that they are doing it in a certain centimeter only. So because with humans, there is a high chances that we try to cut a little extra. That is something which we might not do it, but there are chances that it might go wrong. So that way, robots are being the next future. So tomorrow morning, if we are seeing news is that using AR and VR also, doctors are doing operations, we do not have to worry about it because already that is in place. So I know a doctor in Narayan Hrudayalaya who is already working on VR. And also there is a show in Amazon, so which is a good doctor. So there also it is shown that using VR, they are trying to analyze the entire, operation scene and everything. So even VR and AR is also evolving in the same manner. So when we are talking about machine learning algorithms, or when we are talking about AI, this entire system is working on these two things. So there are some certain logics which we have to use. So that is something which we have to try to automate. So that is something which we are trying to automate it. Now, the other question, like before I joined this call, someone was asking about prosthetics. Uh, Sir or ma'am, I don't know. So I have to give you an answer to it. Prosthetics are also being implemented in the current generation. There are a lot of R&Ds which has gone in and a lot of implementations have gone in. Again, even this has become more automation, but there is a very big loophole over here is when they are using the prosthetics, due to sweat and due to we as a normal human, okay, we try to sweat a lot, or when we try to sweat, there is a lot of slippery happening with the prosthetics. So because of that, there is a little failure and there is no system which is trying to fix it right now. So as in there is no air circulation which is being passed in the prosthetic. So that is the reason that part is not being advanced to such level. Second thing is using prosthetics. So what is the limitations? Limitation number one, it is sweating. Limitation number two, there are a lot of movement issues also coming in. So when you are trying to write a code, sometimes the code is going on a reverse way. So if you have to swing your hand in a clockwise direction, it is moving in an anti-clockwise direction. And then there are some certain angle issues also which are happening. So this is becoming a bit challenge, because when the person is trying to do some trekking, or when the person is trying to run that show for a very long time, or when he's trying to walk for a very long time, there is an issue which is coming, because the timing after a point of time, it becomes very difficult for it. So it is not having a right set of commands. So still I can say that there is a lot of improvement on prosthetics. The fifth point is 3D printing and bioprinting. Now, when we are talking about prosthetics, we can even talk about transplanting, right? So now in the current generation, every one of us are saying that 3D printing has become the next trend. So even though there are a lot of footwear brands which are working on 3D print, which are working on 3D printing, and there are a lot of your cosmetic brands also who are working on 3D printing. So there are a lot of industries who are revolutionizing the 3D printing. Similarly, in healthcare also, for organs to get transplanted, they are just building the organs, but how this entire ecosystem is looking at, or how this entire ecosystem is evolving, that is still in pipeline. So I can say that engineers and medicines are, they are actually doing a tremendous job, and they are building the entire ecosystem of AI, and they are actually evolving over the period of time in a more in a more drastic way. Now, how ML is playing an important role. So early disease detection. That means in the current areas, we see that there are a lot of X-rays and MRIs and CT scans, right? So using AI, what is happening is there is so I have to be, in industry norms. So we have a application which is built where you can try to identify how the mind or how the brain looks like. So it is giving a transparent image of your, or I can say it is giving you a skeletal image. So such kind of medicinal, or the such kind of medical image is going to scan the document in a more faster way, as in it is going to scan the patient's whatever part is. So it is going to scan it in a more faster way, so that the diagnosis or the problem can be figured out in an early stage. So why it should be detected in an early stages? One thing is, it is going to give you a right set of a right set of diagnostic points. So there is a lot of image capturing which works under this. So okay, so there are a lot of image, there is a image capturing company which only works on, capturing all the X-rays and MRIs and CT scans. So they are trying to, so they have been trying to automate that entire thing, and they are, making sure that the doctors are having all the data points in their hand before before having all the reports. So that way, the prediction to the AI algorithms are actually making sure that the risk factor is coming down, and at the same time, before they see a huge symptoms which has been appearing to them in front of it, so that is also being monitored on a real time, and that is something which they are trying to so excuse me. So that is something which they are trying to solve it on a more real-time way. Because of that, what is happening is, if they're trying to solve it in a more real-time, what is happening? They are able to change their habits. So when the patient is able to change their habits, as in their genetic problem, their lifestyle problem, their entire way of living, so they are able to make a more personalized medicinal importance to it. So there is one industry in medicine where already this entire lifestyle changes and everything they do. So that is homeopathy is one such industry where they actually take the entire case of the patient, and depending on his entire lifestyle, they give the medicine. Now, even MBBS, or even the MD doctors, or even the other industries, or even other doctors are trying to work on such patterns, because ML is going to make a historic changes on uh, Okay, so ML models is going to make a historical changes to give more customized treatment to the patient, which makes their life more easier. And also, AI is building more like a virtual assistant in diagnosis, analysis. Example, how this is going to happen over here is, so AI is even going to evolve in creating a generative AI kind of a platform into the healthcare. So let's say if a doctor is facing a challenge to give what kind of medicine it is, so he can enter where exactly this the entire pattern is looking like, or what exactly is the entire symptoms. So using that, it is becoming very easy for him to understand where the loophole is. So once he has the loophole, he will go back and read that particular document, or he will read that particular subject, where he can try to diagnose the problem in a more faster way. So, taking that into example, DeepMind AI is one such thing where where they worked on detecting eye infections to give more accuracy. Now, that diagnosis is something where they made around 94% accuracy, which was a decent uh, that was a decent accuracy which Google tried to figure it out. Now again, they are trying to work on bringing that to 97 and 98% accuracy. So that's how AI in healthcare is evolving. Up next, so we have something called as IOMT, where we see in all the wearable brands. So what do we mean by IOMT, which is Internet of Medical Things? How does this work, or how does this entire ecosystem work? Every one of us use bands, right? So everyone has smartwatches, and everyone has wearable bands, right? So that is the first thing which is making healthcare more smarter. How? It is giving you real-time information on so it is giving you more real-time information on your health. It is telling you what is how much is your heart pumping, what is your ECG monitoring, what is your glucose tracking, how much steps are you taking in a day. If you see that a lot of people will be like, yeah, I have been cycling for so long, and there is a track which has been happening, right? So everything is monitored to make sure that the person is living a little healthier lifestyle. The second thing is where IoT is working over here is, it is working on remote patient monitoring. So this is something where IoT has evolved. Okay, so IoT is providing a platform to the hospitals. So where they are, where the patient is sitting at he's sitting at his place, and there are some certain apps which gives them the GPS information. And based on that, the remote, the patient monitoring is happening so that he can check what is his health condition and how serious it is. So the doctor can also the doctor can, is directly discussing that with the patient to him, saying that there is no proper care which has been happening. So there is a system which has been built for both patient and doctor to monitor it more like a real time. So that is something which we call it as remote patient monitoring. So when you're giving a customized treatment, you need to have a proper care of the patient as well. So that kind of care, hospital is providing it by using some hardware devices, like not just bands, I would say. You have something called as mobile applications. You have something called as a thin band. Like in Healthify Me, you have a small chip, right? So something like they're attaching that with a small IoT chip, and that is being placed in one of your body part. So that is something which is the IoMT device. Next, smart hospitals. So what do we mean by smart hospitals over here is, so the entire hospital will be function on a QR code basis. Now, why QR code? So when you are scanning the QR code, the patient, not the patient, of course, the doctors can identify which patient is, which patient is available at what particular bed, so that he knows that what is the, where exactly is his patient, and how he can track the entire traction of his patient. So that is one thing where smart hospitals are working on. The second thing is hospital bed management. So they are trying to automate it. So anyone who has serious issues, anyone who has general issues, anyone who has some normal issues, so they are being properly stacked in certain set of floors. Why this is happening, or why it is important, that makes, the criticality of the patient will become very important, and at the same time, who would be needing intense care will become very important. Because few people say that, no ma'am, you have, or no sir, you have to put me to ICU and I am in a very big problem. No, that's not how things are working out. So when they are being properly, when they are being properly tracked, their entire body or their entire medicinal activity, everything, everything, based on that, they can even manage which, which stage of bed alignment is needed for him. The second thing is asset tracking and predictive maintenance, of course. So predictive maintenance is basically if there is a proper hygiene check or not, if the patient is properly taken care by the nurses or not. So such things are predictive maintenance. Asset tracking, again, if there is a proper medicine or not. So again, that is more like supply chain management. Asset tracking, you have your drugs are properly kept or not, if you have the right set of drugs or not. If you don't have the drugs, what kind of tools, or what kind of if there is an immediate operation has to happen, if they are lacking with any kind of devices or any kind of important checklist they keep. So AI is able to help them to maintain that major checklist which they have to carry for every operation. So if there is not meeting that checklist, then they will be having an option of going and getting that immediately. So such kind of monitoring is going to make sure that everything is in place, and everything is going to make their life more faster and easier. The last one is AI powered ambulance. So that means nowadays AI has evolved to give all the method. So I can say that using heat maps and using thermal cameras, uh, AI is monitoring the traffic control and particular areas. If I have to give you an example, in India, Bangalore is one such city where they identified the heat maps, and I mean, using heat maps, they identified how intense traffic is at what particular time. And after that, Mumbai was another city where they identified the the traffic management. So when we are talking about ambulance, what happens over here is the AI-based generation or the AI-based system is helping the traffic management in such a way that it is giving an indication to the ambulance person to change the route and to go in a different, I mean, to take it in a different route so that he is reaching the nearby hospital in a very shorter span. uh, Nowadays, even in Google Maps, we see that, right? So whenever we are trying to change the route, it usually, if we are, if you are going in a regular route, it gives an indication saying that heavy traffic, you can try to see a heavy traffic and all those information it gives. Why does it give that? Because it is avoiding or it is asking us to take a different route. That way it is going to help in reducing the time. So that is where the AI powered ambulance are also being helpful. So similarly, so using heat maps and using normal cameras, so they are trying to work on uh, controlling the traffic so that the response time is more faster and more, you know, is into more better way. Now, to give you more, to give you more information on IoT based, how IoT is evolving. So nowadays we even have smart inhalers. So someone who is dealing with asthma, someone who is dealing with breathing issues, inhaler has become another important IoT innovation where people are able to track how much they are using it in a day and how much they generally have to use and how much they are being using. So there is a smart inhaler which has been built, which actually helps us to identify actual versus real. So if at all you're going beyond the actuals, then it will give you an indication to do some sort of exercises, to do some sort of physical changes, so that it helps you to manage. Yeah, so it helps you to manage such kind of behavioral, or I can say, yeah, behavioral issues. Yeah. So now let's talk about big data and cloud computing. So where is big data being utilized, or how big data is being utilized is first thing first. So big data, anytime we see that data is the future. So no matter what comes around or what goes around, data is the next future, and everything relies on data. And similar to this image, every one of us know how big data works, right? So when we are talking about how it is evolving, big data majorly helps you to monitor all the real-time patient analysis. So when you're trying to write an algorithm related to AI, you have to make sure that how much time or how much duration or what is the tenure that a person is doing what activity. If there is any, if there is any imbalance happening, or if there is any kind of um, if there is any kind of data which is being missing, or if there is any kind of, I can say that indefined activity, or if there is any kind of indefined activity happening at that particular time. So that means this health condition is going faulty. So we need to make sure that his entire tracking is happening on a real time, so that that becomes easy to understand when he might be facing a challenge, or when he might be having an issue with what particular problem. So when we are trying to align that entire data into big data, you have to capture every moment and store it in one particular data set. So once everything is stored in that data set, it becomes easy for us to make a predictive analysis, because of which it will become easy for us to monitor how his entire movement, or how his entire body structure, how how his behavioral is functioning. Everything we can try to make a list of it, so that tomorrow when he's coming back with some XYZ problem, it becomes easy for the doctor to say that this was the problem, or this can be the reason for you to have this kind of health problem. So that is where big data plays a very important role. Now, up next, AI-powered clinical research. So when we are talking about clinical research, the first when I came in, okay. So when I was talking about drug development, big data is going to help to capture the data in a more in a more narrative way. So how big data is helpful over here? I'll give you an example. So when you are trying to develop a drug, so every drug works under certain formulation. So let's say that you have A, B, C, D, E. So you have 5 set of elements which has to be which has to be utilized to build a drug. Okay. Now this drug, sometimes the formulation percentages might change. So not every drug should have that entire 100%. So in that E, I mean, till all the 5 elements which you are using. So let's say that the first initial kickoff, you started with 25, 25, 25, 25, 25. So that's 100% and you failed. So this data capturing is very important. Why is it important? Because when you make a when you make a right set of drug, when you're trying to track that entire life cycle of the drug using big data, you have to capture every instance which is being followed. Because of this, what happens is maybe the formulation changes. So right now, after using 25%, we might shift it to 30 and 30, 20, 20, 20, and that kind of, that can be a difference. So sometimes we might just reduce, so we might remove some elements and we might redo that entire drug development. So when you are trying to do all these things, you have to provide the data to big data so that it does the stitching. So it becomes data stitching. And after doing the entire data stitching, artificial intelligence can give some sort of prediction saying that maybe you can work on using so and so formulas so that you can get some sort of information out of it. There is again there can be a huge challenge over here. No AI model is giving a prediction of 100%. That is for sure. So the accuracy, if at all, if it is meeting, so every research institute or every research lab, they fall under a basic category of having at least 70 to 80% accuracy. This is the current market. But these same R&D departments or R&D companies, they are planning to push this predictive analysis to 85%, so that it makes their life more easy. But for that particular 70 to 80%, they have to almost undergo some 100 tests. So clinical research is basically functioning on such kind of, on such kind of analysis and such kind of AI models. So this is where big data is going to come in place. And it is where big data is going to solve the entire, problem of building a new drug. Now, next. So when we are talking about big data, we will be even talking about how blockchain for healthcare records. So healthcare records, EHR is one such thing which helps you to protect the data. So if you understood the big data part of how it is helping in drug, now the same thing implies on, on your health records. So EHR is the application which is which is affiliated by US government. Even in India, we have EHR. EHR is basically an application where all the patient records and all the data points, whatever the patient is providing to us, all the personal information and every information, whatever the patient is providing, uh, that needs to be secured. That should not be going out. So that's a very, I can say that that's a very confidential information from the patient to the doctor. So that has to be blockchain. Recorded, because you need to have a lot of authentication, and since it is a lot of personal information, there shouldn't be any sabotaging of the, there shouldn't be any sabotaging of the data. So for that reason, having blockchain and having blockchain should be the is the better future of it. Now, when we are trying to talk about healthcare data processing, cloud-based data processing reduces infrastructure costing. Simple example for that is, if everything is pushed on cloud, you don't need to have a physical, you don't need to have a physical servers. In India, we still, I mean, there are almost 65% of hospitals who are still relying on external servers. So just imagine if they can be pushed to cloud, how much amount like money and how much amount of costing, infrastructure costing, or how much amount of savings would have happened. They might be spending pretty less when it is pushed on cloud. So that that is something where where we have to improve ourselves, because cloud computing can help you to help in faster diagnosis and way faster result oriented things. So how, when we are talking about this AI clinical research, IBM Watson is one such example which we are talking. So they record somewhere close to million data sets on how the treatment has to happen, and uh, and how exactly the treatment is happening, and how the AI is functioning on adhering to all the natural language documents, and how is it reading all the analytics part using deep learning and artificial intelligence. So that is where IBM Watson is working to reduce the time on medical papers and medical documentation to give more better treatment, as in to give more diagnostics solution to the healthcare sectors. Yeah. The next is robotics and automation in healthcare. So as the image you see over here, robot is something where you can see that it is attached with a camera, which is attached to a monitor out there. So there is a camera which is being kept on top of it. And when you're trying to tear up the body, or when you're trying to, cut a particular area in the body, so robots are giving more precise information, or robots are giving more precise surgeries also. So this is where it has been revolutionizing. The second thing is, AI is powered in terms of giving the prosthetics as well. So where you see that if there is any, if there is any organ which needs to be replaced in a more real-time basis. So using neural networks, it is trying to diagnose where exactly the part has to place in at what particular dimensions. That way, that way robotics is evolving to give more real-time location preference as well as location gathering. So that is saving a lot of energy, and that is saving a lot of time. The third one is automated pharmacy system. Simple. If you're using a certain set of drugs, uh, using robots, it is going to, it is going to make sure that if that kind of proper dispensing, proper drug is being provided to you or not. So that kind of pharmaceutical system enhancement also robotics are doing. Again, like I said, I gave you an example of UAE-based company UAE-based hospital where they are completely having robots. What that robot is doing, that's an example which I have mentioned over here. So robotic nurses are reducing the workload in the hospital. So that is basically assisting all the patient in a more real-time way. It is doing all the routine checks, because every nurses will have a basic routine check to be done with every patient. So it is very important for them to do that. So if you're having a robot, it's simple. It is working 24/7. It is having an eye on every patient. If at all they see any kind of disturbances, they are being tracked down, and their vitals, everything has been tracked down. So that way, the human can actually work in multiple other things rather than just working on a single aspect. So that way, robots are evolving over the period of time. So tomorrow, if we see any kind of hospital saying that we are having robotic nurses, I think we shouldn't be shocked on that, because that is going to be the future. So humans, human intervention will become more to work on a lot of R&D and a lot of operational kind of an activity, and very less in terms of managing the people. So that is where we can see the evolution being happening. Up next, we have 3D printing and bioprinting in medicine. This is where I was been talking about. So the organal, the organ implanting, the customized prosthetics. So anyone who has any kind of medical devices or any kind of 3D printings. So people are so certain set of prosthetics can be used by using 3D printing. Not everything. I mean, you cannot literally use a liver or a heart because that is a very important. So that's a very important organ for a lot of people. But there are some certain prosthetic uh, body organs which can be printed on 3D. So that is being used in multiple hospitals already. The second thing is bioprinting human tissues and organs. As simple as that, anyone who wants any kind of artificial organs. Uh, there are, I don't want to give some examples in this because there are a lot of people who are doing this in the real world, including our actors, including our own, beloved role models. So this is already happening in a real time to a different level altogether. Uh, Next, if I have to give you some examples on what kind of organs or what kind of tissues, I can do that. So people say that there are a lot of actors who had grown their, who had their hairs being transplanted using, using prosthetic, I mean, using aesthetics and everything. Yes, this is where they are using their human organs, like human tissues. So hair growth, then you have your artificial beard growth. Few people have their skins that has been, that has been pushed back so that they don't look aged. So anti-aging is another bioprinting possibilities which is already happening in the current market. People even do their prosthetics on their lips. So they do this lip infusing. So that is something which people are doing nowadays. So tomorrow, if we see a lot of people working on, I mean, looking on plastic, we should not be, we should not be scared of it, because that's where people are more inclined towards it. Uh, Now, why are they doing all these things, or why they want to use that? Of course, that is for fashion, but more and more of 3D printing and more of these things are going to help in reducing the cost of high-end medical devices. So if you are actually going for something on a very high scale, uh, non-affordable kind of prosthetics, it will become very difficult. So if at all you have to, people actually charge somewhere around 1 to 2 lakhs for having prosthetics. If you are getting the same thing in somewhere around 80 to 1 lakh, that becomes a little affordable and that becomes a little cost reduction, right? So that is possible using 3D printing and bioprinting. Examples, yes, scientists are still experimenting on 3D human skins. Uh, like I said, anyone who is, we have a lot of actors who have been working on transplanting their hair and, your skin, your lips, whatever you want to call it. So everything is still under, experiment. So any body part have to be replaced using transplant is 100% possible using 3D printing. I can only say that by the end of it. So what is the future? Or what are we trying to, what are we trying to talk about the future over here is digital twins in healthcare. So over here, like we all know that the entire globe works on engineers and healthcares. They both will be working together to create more of an AI-driven models, AI-driven patient experience, AI-driven predictive analysis. So how are you going to work on that? There will be a lot of data management which goes around, and there will be a lot of predictions which will be rolled out to every patient. A lot of people has to know this. The first and foremost country which majorly works on healthcare is Switzerland. So that is whatever any changes we see on healthcare, Switzerland will be the first country where we see uh, where we see that these kind of changes are coming across. Uh, but people think that it is US. No, US is falling on fourth or fifth position. Uh, Fortunately, India is on top 10 places where we work on building the healthcare to a different tangent. So that is something which that is something which we can see in the nearby future. Engineers and doctors will be working together to build the AI model to the best way possible. The second one is brain-machine interface. That means any kind of restoring movement or any kind of paralyzed patients, we can try to understand and we can try to read where exactly the problem has happened in the body. So that is where a lot of R&D is happening in the current market. So why, I mean, how they have been paralyzed for so long? Can there be any cure to it? So that kind of predictions are still happening in the globe. So maybe we can expect a lot more changes on that. The third one is nanotechnology in medicines. So there are a lot of US based companies who are building on nanorobots where they can help in terms of precision drug delivery or precision so if we see that if we see that there is a lot of nanotechnology which has been involved to build the right set of drugs or to make sure that the right set of formulas or right set of formulations are done. So in such kind of areas, nanotechnology is playing a very important role. The last one is AI powered mental health support. Uh, Now every one of us know the story behind Sushant Singh Rajput, right? So he hung himself because of depression. But there are a lot of companies who are trying to build a chatbot which is going to be future proof. What do we mean by that is, so this kind of chatbots are going to detect an early stage depression, and that can help, uh, that can help the psychiatrist to talk to them directly and to bring them out of that depression. So AI is working on building a health mental support. So that can be the next future. But again, this is still in pipeline, I think, because I have seen a couple of news on this, but even I haven't seen a concrete information on how they are trying to work on this. But for me, what I felt is, or if I have to give you an analysis, which I have been talking to a couple of doctors based on that. So this chatbot is going to ask a couple of questions to someone who is in depression or to someone who is in their mental state. So it tries to understand by asking some certain set of questions, and based on that questions, it makes a prediction saying that what stage of depression he is in, because there are some certain stages, is what I heard. So if he's in an initial first two stages, then that shouldn't be a very concerning point. If he's beyond a certain limit, then such kind of things either has to go for a go for a diagnosis or undergo some sort of medicines. Anyone who is beyond 5, maybe they have to go to a rehab. So something like that. So there is some sort of levels for identifying depression also. So like I said, I am not very sure of it. This is something which, this is something which I'm trying to tell you on the kind of discussions which we had. Next. So where are engineers and all these things? So because we have been only talking about healthcare techs, healthcare techs, healthcare techs. The answer is very simple and straightforward. Engineers are actually, engineers are actually bound to work on multiple health sectors or to multiple disciplinary research. So first thing first, into any kind of research or into any kind of, any kind of analysis to be done on any kind of drug development or any kind of R&Ds. For over there, engineers and medicine are going to be the next future. Second thing is student innovation. That means if anyone wants to prepare a diagnosis tool to build how, so even if they have to take a project, something related to medical devices, how those devices can work, how those devices can try to automate, or if they're trying to understand the maintenance of that particular device. So if they can try to make an AI driven maintenance of that particular medical device, that can help in solving the issues of maintaining that particular machine. So that can be a very good innovation idea for a lot of engineers out there. Third one is industry academia collaboration. Simple, engineering and healthcare has to start working on a lot of research laboratories and have to start working on a lot of have to start working on a lot of rehab laboratories. So this way, what happens is engineers also can start making more predictions on cutting edge technologies to make sure that healthcare is being taken to a different level altogether. So to summarize our entire discussion, I have three case studies which I have lined up. So I'll try to give more faster information on what their problem statement is and how their solution is. I hope, you guys have understood how this has been evolving over the period of time. So first case study was how Google DeepMind and AI has been working together. So the main problem statement was doctors actually used to face a lot of challenge with manual X-rays and MRIs and CT scans because of once this was being diagnosed, it used to take a lot of time for the people to get those reports. So what what Google did over here is they made a predictive analysis. They trained a lot of AI models to make sure what kind of diagnosis or what kind of problems were coming in place. So taking that into account, uh, Deep DeepMind figured out a couple of issues where the first issue was lung cancer. So AI predicted 94% of accuracy in predicting the lung cancer. The second one is eye diagnosis. So what did it do is it actually diagnosed a good amount of diagnosis, and that is you know that helped them to track down what kind of diseases it is. Is it a cataract disease, or is it a is it a vision disease, or what disease it is? So that helped them to track down beyond 90%. Next, how was the ecosystem built? So they prepared an algorithms in such a way that they used LLMs and big data. So this was the main data points where they figured out where where they trained the AI model to such a way that what were the design patterns or what were the disease patterns which came in over the period of time, and they had to recognize what were unique and what were common, and that is where that is where they're tailored the entire AI model to make the prediction look more data centric rather than having a very open-ended points. So that way the AI algorithms, they define all the all of that in such way. The second thing is cloud data storage. So when they were doing all these things, they were storing all the data in the cloud, and they were sharing the similar kind of patient reports, so that the patient is also very well aware about what kind of disease might come up to him or what kind of problems might come up to him. When he saw such kind of problems, it was easy for him to have an interaction with the doctor saying what kind of problems he is facing, for him to make sure that this entire assist had made the doctor to give him more data driven decisions rather than giving him a vague decision. So when he saw that this was the particular diagnosis or this was the particular problem, it helped him to clear out that problem in a more faster way. So that helped him to make sure that he's out of, he's out of danger in a more with a speedy recovery. So what was the outcome of it? So AI algorithms helped him to diagnosis a time to time, a time to time medication and a time to time, a time to time approach, which helped him to reduce the tat of curing the problem in a more faster way. Up next. Okay. The second one is wearable bands. Every one of us know what is Apple bands and Fitbit bands, right? Um, Now, I'll tell you how this is. I mean, this has happened with me also, okay? Honestly speaking. So, this helped me as well. So, I can give you a real time case study of mine itself. So, this is something which you guys can read, but self experience is always good, right? So, literally, when I was having my Apple Watch a couple of, I think, months back, so I met with an accident. So I actually fell down and I had some scars on my body. So what happened over here is my Apple Watch detected that I got into a trouble, and it all of a sudden indicated saying that, okay, there is an issue which happened to me, and it started. So first thing first, it asked me an information that should I send a message to all my nearbys. So like as in nears and dears. So first thing it asked me if I have to send a message to everyone, and then it said there was a indication which came in that I can drop a message to few people, or I can call to all of them saying that I had a problem. So honestly speaking, I could have, if I would have delayed it by another second, my entire family would have had that information that I got into a problem. It's just a minor accident, okay? I fell down and I just got scars and I got rashes all over my arms and my knees. So that is something which I had to say that. So similarly, there is another incident which happened in Pune. Okay, one of one of an aged person who was in his 50s, I think, while he was driving his car to go back home, all of a sudden he had a heart attack. Uh, Believe me or not, this entire incident has happened where that was being recorded and that was being shared online, and it became viral, and that became very important aspect for Apple people to market it to a different level. So what happened is he was wearing a Apple smartwatch. So directly it sent a message to a nearby hospital. It sent an alert, and once it sent an alert, the person, he sent out an ambulance immediately to that particular location. So using GPS and using geo, I can call it as not GPS. It using geofencing, Apple Maps sent a location to a nearby hospital, which was being tagged with Google Maps. And they asked, there was an immediate action which took, where there was a ambulance which came in that particular road. There was a message which was sent out to his family. So where his wife and his kids, everyone got an information. And within no time, in 30 minutes, he is in hospital. Point number one. Point number two, his families are available in that hospital asking him for what has happened. Third thing is, people around him actually helped them to, have actually helped the patient to take to the hospital. They took the entire crowd over there. They somehow managed to pull him out of the car, and they put him on the stretcher and they took him to the hospital. That way, it saved the life. It saved the life of that particular person, and that was a very big news. So similarly, where this entire story has these itself. There was a problem with certain diagnosis and using ECG and heart rate and all those things. So that is something which that is how the ecosystem has built. So Apple have saved a lot of lives like this. Now, if I have to give you the technical side of it, what did Apple do is it tracked down the entire maps using geofencing. So there was a geofencing which was being sent out saying that I am at this particular location. Second thing is by sending an immediate alert to the entire people. There was an SOS emergency. So that was being a message which was sent out to all the nears and dears. So that was the second set of sensors which were being attached. The third thing is this tracking was also there in my Apple system. So my fitness, it also reported that I met with an accident. So there was a data which was being captured, and because of this, what has happened is it helped me to control my BP. It helped me to control my anxiety issues. It helped me to control my, it helps me to control my entire health issues. So if at all I'm being if I be anxious sometime, the watch used to indicate me saying that take a deep breath. It used to calm my mind. So that way my entire body used to function in a more normal way. So this entire data was pushed on big data, and then it gave me a healthier life, actually speaking. So this is a real story which I am talking. Now, the third one is big data and predictive analysis. Yes, so this is where our analysis is happening on a documental way. A lot of research come across on a daily basis, and doctors and researchers are actually spending millions and millions on money into writing medical papers. So to make sure that there is a real-time treatment which is happening. So to avoid such kind of problems, what has happened is uh, big data actually analyzed the old set of data. So it is IBM Watson is an AI tool. If many of you don't know, so it is just similar to what DeepMind does. IBM also has their own tool, which is IBM Watson, where they actually take the document over there, they analyze what is there in the document, and it captures the image out of it. It is just a simple uh, image to text format which happens over there. Now, when you're trying to do the analysis, how IBM Watson has worked over here is, so that has recorded the entire patients and doctor treatment, and also what kind of medication is used for what particular purpose. So their documentation work has become very easier and faster, so that if there is any incurable disease, IBM Watson had made an analysis and given the model in a more in a more strategic way to cure a particular problem. So where did it solve the problem? So there was a cancer treatment which was happening for one particular patient, and IBM Watson, it actually took the entire data sheets from the patient. It identified what the patient's problem was and how the patient problem came in. Based on all the research document which was already sent out to the IBM Watson backend, it easily calibrated where the diagnosis or what kind of cancer it is, and immediately sent a certain set of information to the doctor saying that this is the kind of analysis and this is the kind of treatment can be provided. That help the doctor to give the right set of methods and right set of treatment which cure the patient's cancer. So that's where AI is functioning. So to conclude everything, yes, engineers and healthcare have to work together, restoring and paralyzed treatment and everything. So if you have any questions, I'm good to go.
Sir, I have a question.
Yeah.
Yeah, it was very informative regarding the smartwatches also. How was it useful for our health purpose? I'm also using a smartwatch, especially like during the summertime, my BP levels will go down. So with the help of the sensors, it will indicate me like to take a precaution.
Correct.
But there are some videos says that if you are using the smartwatches, you will get so and so this kind of disease and all. So making panic, but I don't understand that really that R&D says like that. I'm not sure on that. So can you help me with my doubt actually? That is
Okay.
true that if we are using the smartwatch, it's going to get different kind of diseases because there are different videos. Even sometimes doctors also will post. So that is creating like a panic that
Okay.
we use it or
Uh,
not.
Honestly, ma'am, even I sold my Apple Watch for the same reason and I regret it. So, whatever you are hearing is 100% true. I can say that. But having said that, we need to limit ourselves. Okay. I know we are all using smartwatches and, smart digital watches and everything. No doubt about it. But because I have a doctor in my home, which is my wife. So she told me that we can use our wearable bands to an extent where it is not harming us. So like you said, ma'am, if you try to make an analysis or if you're trying to, always have a check on how your health is, or is your BP high, is your BP low, is your, is your, what is that? Is your blood pressure is, I mean, if you're properly pumping 92 or 95 every minute, if you're trying to have that regular checkups, what happens is people get anxious. It's a human tendency, right? If you don't function, if you see that your body is not functioning as per as per its standard, we get anxious. We feel like, oh my god, there is something wrong and there is something issue with us. So that kind of anxious spirit will come into our mind and that will create a lot of mess. So for that reason we need to avoid it. At the same time, rather than completely avoiding it, have a track on your entire body. That is something which is needed. As in, what I mean by that is, when you know that you are having a little, little problem when when you're in a crowd. So sometimes people have this phobia, right? So they don't have, so they cannot withstand crowd for a very long time. So at that time, when you know that your body is not listening to you, it's okay. I mean, just move out from that particular crowd. I know wearable are creating a big issues. Um, if you ask me a straightforward answer, the answer is 50-50. Use it only when you're doing it for workouts. Don't use it for your day-to-day activities because our work life and our health, our lifestyle will create a lot of mess. And because of that problem, we will have that phobia every time to check what is happening. So my personal advice is try to keep it as easy as possible and use it only when you're doing workouts, at least walkings or such way. That can be little benefiting.
It we can't wear like how regularly we will use the analog digital watches normally. So it's better to avoid wearing like that continuously.
Yeah. And yeah, main thing, never use your watch when you're sleeping. Please, no. A big no.
Okay.
That is, that's a very big problem. I mean, because of that, people are having heart attacks and people are having brain tumors. If at all you are using that during sleep. And there is a lot of research which has happened for that as well. Mr. Tushar, I will be sharing it with Narendra sir, and maybe he can share it with you.
Any questions from the audience?
No questions? Hmm. Ma'am, yeah, Kushi ma'am, actually, your question is very interesting. Like I said, you don't need to use it throughout your entire day. Use it only when there is a requirement. So that is during your workouts, or don't use it during your any kind of functions or anything, because that time automatically everyone will become anxious. Everyone will have lot of things to work upon. So we need to use it in a very minimalistic way, so that we are also happy, and even our body is also happy. IoT healthcare, that only comes when you're, IoT healthcare, it only comes when you're trying to talk to a lot of healthcare people and everything. Good. Suppose you want to monitor a patient, then in those cases where we ask patient to wear. Yeah, that is again, see, when you're trying to, I get your point. So when you're trying to say that you want to monitor his entire day schedule, that time it is important. But uh, the phobia which we have, or the news which we hear, that you should not be wearing it for a very long time, and that will give you a lot of problem to it. So I'll tell you how that works. Okay, every smartwatches has a backlight. Okay, there is a sensor which has been attached in the back. If you are also using a smartwatch, you can go back and check. So there is a green light which is being passed. So these green lights are passing through our veins, which is interconnected with our nerves. And if you are technically giving a shock to those nerves, so that's called a silent treatment. So using those shocks, what is happening is you are trying to awake the nerves which can be a little less harmful, and that becomes a very that becomes a very issue when you're trying to awake such kind of nerves. That is the reason you will have all this paralysis problem, and you will have all this you'll have all this brain strokes coming in, just because of that kind of small mistakes we do. But bands are something which is different. Watches are different. Bands, you have a company named Healthify Me, where they ask you to use the band to your forearms, or to your to your biceps. Using such kind of bands are important. So they will not ask you to use they will not ask you to use a smartwatches or Fitbit. So that is where the correction comes. So if they're asking you to use bands, they ask you to use it for your forearms, in your forearms, on your biceps alone. So if I have to give you a little more detail about it, Cristiano Ronaldo is one such person who uses these kind of bands to track his health monitoring and everything on a day-to-day basis. And he uses his bands on his forearms. He does not use a band on his wrist. Even in Virat Kohli is also one such player who uses his band on the biceps and not on the wrist. So bands are different and watches are different. So I think that is where the difference comes. So should IOMT medical implant be given AI decision making power to act independently in life-threatening situation? Mr. Vamsi, not technically, yes. Uh, Rather than giving a independent decision making, uh, it can be treated in such a way that your analysis, or your medical device analysis, can help you to, not life-threatening situations, of course, because that will be handed over by the doctors alone. So I would say no. Oh. So this is my LinkedIn profile.
Okay, thanks for
In
your
fact, I
profile.
even have mentioned my number, so that shouldn't be a problem. Narendra sir, can I share that over here, or should I
Yeah,
share
sir.
that
You
with
you can share it, sir. Not an issue.
Okay.
Yeah.
Khushi ma'am, did I answer your question, or is your question still active? Okay.
Okay. So this is Vikas again. Thanks for you sharing your knowledge, and your discussion has broadened the bandwidth of our understanding of IoT in medical health. I definitely we have taken back very important points from your session, and I personally liked your case studies. So thanks once again for joining us today for the faculty development program. Thank you so much.
Thank you, Aditya, sir, for your valuable information.
Thank you, sir. And anyone has any questions or any queries, you have my number in there, so we can directly get in touch. Thank you so much for your time, guys. And oh, okay. Thank you. Okay, sir. It was really a pleasure meeting every one of you. And anyone has any questions, we can be in touch. Thank you so much.
Sure, sir. Thank you so much.